Hidden beneath the waves of the western Pacific Ocean lies one of Earth's most fascinating natural wonders, the Marianas Trench. As the deepest point in the world's oceans, it stretches across 1,500 miles, cutting into the seafloor like a scar, with depths reaching nearly 7 miles. This immense underwater chasm has fascinated scientists, explorers, and dreamers for over a century. In 1872, the HMS Challenger, a British research vessel, embarked on the world's first oceanographic expedition. At the time, people believed the ocean floor was flat, lifeless, and largely unremarkable. No one expected to find anything extraordinary. For 4 years, the Challenger crisscrossed the globe, covering 70,000 miles. Using ropes weighted with lead, the crew painstakingly measured the depths of the ocean at regular intervals. It was indeed tedious and exhausting work, but the results were groundbreaking. When the Challenger reached the western Pacific near Guam, the crew made an astonishing discovery. As the weighted rope plunged deeper and deeper, it seemed endless. Finally, at nearly 5 miles below the surface, it struck the seafloor. The scientists aboard were stunned. This was not a simple depression, it was something far greater. This finding challenged the long-held belief that the seafloor was flat, igniting curiosity about the true nature of the ocean's depths. In the mid-20th century, sonar became a revolutionary tool for mapping the ocean floor. Developed during World War II to detect enemy submarines, sonar used sound waves to measure distances underwater. When a sound wave hit the seafloor, it bounced back, allowing scientists to calculate depth with remarkable accuracy. In 1951, a British research ship returned to the western Pacific, equipped with advanced sonar. This time, they uncovered something even more astonishing. The deep hole wasn't just a hole. It was part of a massive underwater trench, stretching for 1,500 miles and plunging to depths of nearly 7 miles at its southernmost point. This area, later named the Challenger Deep, remains the lowest known point on Earth. The sonar maps revealed a world far more complex than anyone had imagined. Vast mountain ranges and deep canyons crisscross the seafloor. The Marianas Trench, in particular, stood out as a geological wonder, raising new questions. How did such a trench form? What forces shaped it? And what secrets lay within its depths? To answer these questions, scientists needed to explore the trench firsthand. But descending into the trench posed enormous challenges. The pressure at its deepest point is more than 1,000 times greater than sea level, equivalent to being crushed by the weight of 50 jumbo jets. Surviving such an environment required groundbreaking engineering. In 1960, Swiss scientists Auguste Piccard and U.S. Navy Lieutenant Don Walsh piloted the Trieste, a specially designed submersible, into the Marianas Trench. The Trieste's thick steel sphere protected the crew from the crushing pressure. Inside, the two men endured cramped conditions and freezing temperatures as they descended at a painstakingly slow rate. After nearly 5 hours, the Trieste reached the bottom of the trench. When they finally touched down, they spent only 20 minutes on the seafloor due to safety concerns. Yet in that short time, they made a groundbreaking discovery: life. Pale shrimp and fish-like creatures swam through the water, while the seafloor was coated in a dark, muddy substance Piccard described as diatomaceous ooze. This confirmed that life could exist in the most extreme depths of the ocean, a finding that thrilled scientists around the world. In 2012, filmmaker and explorer James Cameron followed in the footsteps of the Trieste crew. Piloting the deep-sea Challenger, he reached the trench's depths, where he observed strange microbial mats. These filament-like structures, made up of microorganisms, thrived on chemicals in the rocks, performing chemosynthesis, a process similar to photosynthesis but without sunlight. These microorganisms form the foundation of a deep-sea ecosystem, supporting larger creatures in an environment devoid of light. Cameron's journey highlighted the trench's rich biodiversity, showing that even the harshest environments could harbor life. In 1996, The unmanned Japanese submersible Kaiko achieved a new milestone by diving to 10,897 meters. Its mission was to collect samples from the microbial mats Picard and Walsh had documented decades earlier. Kaiko's findings challenged previous beliefs about life's adaptability, discovering bacteria that not only survived but thrived under immense pressure. 2 years later, Kaiko returned to the trench and made another startling discovery: Hirondelle, a giant amphipod species. These shrimp-like creatures were found thriving at depths where the extreme pressure should dissolve the calcium carbonate in their shells. Scientists later discovered that these amphipods use chemicals in their gut to extract aluminum from seafloor mud, reinforcing their shells with a type of natural armor. Kaiko and other submersibles have also captured footage of other trench inhabitants. Among the most peculiar are holothurians, or sea cucumbers, like the bizarre-looking sea pig, which uses tentacle-like appendages to sift through mud for food. Some scientists believe that what Picard described as a fish during his Trieste dive might have actually been a sea cucumber. More recent discoveries include the Mariana snailfish, identified in 2014 at depths of 8,000 meters. While this is still far shallower than the Challenger Deep, it's the deepest dwelling fish ever recorded. These translucent, ghostly creatures provide a glimpse into the adaptations needed to survive in such a hostile environment. Other remarkable life forms in the trench include the xenophyophores, giant single-celled organisms that grew up to 20 centimeters wide, and predatory tunicates, known as sea squirts, which anchor themselves to canyon walls and snatch passing prey. Meanwhile, bioluminescent fish like the deep-sea hatchetfish blend into their surroundings using their natural glow. These discoveries reveal the trench as a thriving, alien-like ecosystem, a stark contrast to the lifeless void once imagined. Understanding how the trench was formed required a deeper dive into the science of Earth's crust. By the mid-20th century, scientists had discovered that the Earth's outer layer, or crust, is divided into massive slabs called tectonic plates. These plates float on the semi-molten mantle below, constantly moving and reshaping the planet's surface. The Marianas Trench lies at the boundary where two tectonic plates collide. Here, the heavier Pacific Plate is forced beneath the lighter Philippine Plate in a process called subduction. As the Pacific Plate dives into the mantle, it creates the trench, a massive crease in the ocean floor. But subduction does more than create trenches. It also drives volcanic activity. As the descending plate melts, magma rises to the surface, forming a chain of volcanic islands near the trench. These islands, the Mariana Islands, mirror the trench's curve, offering further evidence of the powerful forces at work below. While subduction explains how trenches form, it doesn't fully explain why the Marianas Trench is the deepest on Earth. Scientists believe its extraordinary depth is linked to the age and density of the Pacific Plate. At 170 million years old, the seafloor at the trench is amongst the oldest on the planet. Over time, the crust has cooled, compacted, and become denser, allowing it to sink deeper into the mantle than younger crust. The trench's southernmost point, the Challenger Deep, is even more extreme. Scientists think this area is deeper because of a unique feature, a narrow tear in the Pacific Plate. This tear allows the plate to sink almost vertically, creating an exceptionally steep and deep section of the trench. One of the most remarkable aspects of the Marianas Trench is its role in Earth's recycling system. As the Pacific Plate subducts beneath the Philippine Plate, it carries water, sediment, and crust deep into the mantle. This material is eventually melted and reformed, fueling volcanic eruptions and creating new crust at ocean ridges. In this way, the trench helps recycle Earth's crust, balancing the constant creation of new crust elsewhere. Despite decades of research, much about the Marianas Trench remains unknown. Only a handful of missions have ventured into its depths, and less than 5% of the world's oceans have been explored. Scientists suspect that the trench harbors unique ecosystems and geological phenomena, but its remoteness and extreme conditions make exploration difficult. One lingering question is why the Marianas Trench doesn't cause the devastating earthquakes often associated with subduction zones. The answer may lie in the trench's unusual geology. Core samples from nearby mud volcanoes suggest that the plates are grinding against soft, slippery rock, which reduces friction and prevents major quakes. And that's all we have on the Mariana Trench for today. If you found this video fascinating, please do well to like, share, subscribe, and also leave us a comment below on what else you find so fascinating about this mysterious site. Until then, we'll see you next time.